Good morning, good afternoon. We're going to be talking about scientific notation. I can statements, or I can convert between scientific notation and standard form, and then I can compare numbers written in scientific notation. First, we have to define a scientific notation. It's just going to be a shorthand way of writing a very large or very small numbers. You're going to have the number and only one number before the decimal. So here's my decimal, a number 1 through 9. So if I have, I don't want 0 there, and I don't want 10, 11, 12, because that would be 2 places before my decimal. So I just want one decimal number, or one number before my decimal, and then all the rest of the numbers after. And then I'm going to have it times 10, and it's going to have an exponent here. So large numbers have a positive exponent when written in scientific notation, and then small numbers will have a negative exponent when written in scientific notation. So that's pretty important to remember: large, positive, small, negative. Okay, so using the rules of exponents and powers of 10. So first, our standard form, 725,000. That's standard form. 0.006 or 6 1,000ths. Okay, product form. That means that product means multiply. So this is in product form. 7.25. Get rid of some of this stuff here. Make it a little bigger. So I'm showing the product of two numbers here. 7.25 or 7 and 25 hundredths, times 1,000. This would get me the same thing as here. And then this would be scientific notation. Writing this kind of bigger number, it's going to be 7.25 times 10 to the 5th. The only thing here that we did, get this up here, the only thing that we did here was we changed this 100,000 to 10 to the 5th power. Those are the same thing. So we have the same numbers. This is just written in scientific notation, and this is in product form. This is in standard form. Okay, so one thing I like to remember is, like here, this is a big number, so I'm going to have a positive exponent. My decimal is an imaginary or invisible decimal right now. It's right there at the end of my number. And I need to move it so that I only have one number before. So my decimal, I want to be right here. I want to move it all the way from here all the way to here. But I can't lose these other numbers. And all these zeros, I could write them, but that's just going to take up room, and that's what I'm trying to get rid of. So I'm trying to get rid of all of these here. Okay, so this is my first step, is writing my number that's going to be multiplied by my power of 10. But now, it's not just going to be times 10, it's going to be times 10 to a certain power. So how many places did I move it? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to have a 9 here. And now if I were to multiply this out, 10 to the 9th power, and then multiply it times 3.42, I should get my original number here. And that's one way you can check your answers. Okay, remember, really small, we're going to have negative numbers. So this number here, I need to put a decimal in between to get my first number. So 8.9. See how I just have the one number before my decimal or to the left of my decimal, and then all my other numbers go behind it. Well, other than 0, I only have the 9. Okay, and then it's going to be multiplied by 10 to a certain power, but I need to figure out what that power is. So 1, 2, 3, 4, 5. So it's going to be a negative 5. There's other things you can remember, like if I move my decimal to the right, this number will be negative. If I move my decimal to the left, this number will be positive. Okay, that's good to just start to learn, because we're going to be adding numbers and changing them from certain forms. And we're going to have to remember that if we make my number bigger, this number is a really small decimal. Well, it's becoming 8.9. So if we make this number bigger, we make this number smaller. If we make this number smaller, we make this number bigger. Okay, so it's kind of a scale. One goes up, one goes down. Okay, so here, again, my decimal is right here. It's my invisible decimal. I need to make sure that all of this is in my number. So it's going to be 7 decimal, that's 008. So 008. All the rest can go away. But I still need to count. It's going to be times 10, and I got to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, if I see here, I got 7 point, if I put that decimal here, 7.008, 7.008. So I made this number smaller, so I'm going to make this number bigger. Okay, this one, again, I'm going to need, my decimal will need to be right here. So 5.26 times 10. I'm going to make this number bigger, so I need to make this number smaller. So it's going to be a negative, and I need to count. 1, 2, 3, 4, 5, 6, 7. So negative 7. Okay. Now, turn the page. Now, you need to write the numbers in standard form. So again, let me get out of this one. So we have positive exponents, negative exponents, and we need to write them into standard form so they don't, right now it's in scientific notation. So we have 4.1, and that decimal is going to move 4 places. If it's positive, it's going to move to the right. So it was right here. Sometimes I like to just add a bunch of zeros if I get confused, and I know it was right here, so I need to go 1, 2, 3, 4. So it would go right here. And then if I had a pencil, I could erase these two here. I can also leave them. That's not a big deal. But this would be 41,000. This number in scientific notation is 41,000 in standard form. Okay, here I have a negative, so I'm going to go to the left. I'm going to make my number smaller. So 7, 2, 3. So I need to go 1, 2, 3, 4, 5, 6. And I would check my answer here, because sometimes, like I said, I like to add a bunch of zeros and then do it. Kind of, and I even do the 1, 2, sometimes. But with a pen, I don't want to make it all messy. But if you had a pencil, you could sure do it. So it was right here, and I'm moving it 6 places. 1, 2, 3, 4, 5, 6. So these two numbers are the same number. The scientific notation here is just a shorthand way of writing this big number. Okay, let's do 6 and 53 hundredths. It's a positive number, so I'm going to move to the right. 1, 2, 3, 4, 5, 6, 7. I'll double check my answer. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay, so let me rewrite my answer. 2, 3, 2, 3, 4, 5. Okay, putting in my, so there I have 65,300,000 as my answer. Okay, 9.2. My decimal is here. I need to go to the left. You could also look at that as a arrow. So I need to go that way. So 1, 2, 3, 4. Double check my answer. My decimal is here. I need to move it 4 places. 1, 2, 3, 4. Okay. So the next thing we're going to do is we're going to be comparing numbers in scientific notation. Well, the first thing you want to do is you're going to write the numbers in scientific notation. If they're two numbers, one's in standard form, you're going to want to write it in scientific notation. And then you're going to compare the exponents on the powers of 10. If they're different, the one with the smaller exponent is going to be the smallest one. If they are the same, you need to compare the decimal numbers. The smaller decimal is the smaller number. And then you're going to write the answers in their original form. Okay? So first, order these numbers. We want to write them all in the same form. So here we have two numbers that are in scientific notation. Let me just get these a little more distinct here. And then this one is not. So I want to write this one in scientific notation. So remember, I want my decimals here, I want to make it between the two numbers. So I only have a number, this number right here has only one decimal place before that decimal, or to the left of the decimal. And I move it 1, 2, 3, 4. So it's going to be times 10. Now, again, sometimes I forget if it should be negative or positive. Well, this is a bigger number, so this is going to be a positive. Or I like to think I'm making 23,000 into 2.3, so I'm making this number smaller to 2.3, so I have to make this number bigger. Okay, so then I have 2.3 times 10 to the fourth, 3.4 times 10 to the third, and 2.2 times 10 to the fourth. Well, least to greatest, the smallest one is going to have the smallest exponent. So I'm going to write 3.4 times 10 to the third. Okay, my next one, these two have the same number or exponent on the 10, so I need to look at the decimal numbers, 2.2 or 2.3. Well, 2.2 times 10 to the fourth, because 2.2 is smaller than 2.3. And then I'm going to write my 23,000, because I want to write it in its original form. And they're from least to greatest. Okay, the next one, again, I have two numbers that are in scientific notation and one number that is not, so I'm going to put this one in scientific notation. So 4.7 times 10, remember I'm making this number, it's a really small decimal number, and I'm going to make it a bigger, I'm getting bigger, so this number is going to get smaller on my exponent. I'm moving it 1, 2, 3, 4, 5 places, so it's going to be a negative 5. Now here, negative 4, negative 5, negative 5, which is smaller. Negative 5 is going to be smaller or further away from 0. So I have to look at these two first. Well, 4.8 and 4.7, I'm just going to look at those numbers. So if I think which one is smaller, it's going to be this one. So 4.7 times 10 to the negative 5th power. Oh, I should have written it like this, but that's okay. Then 4.8 times 10 to the, I'm running out of time, and then our bigger exponent is going to go last. Okay, and I'm going to kind of go through these quickly. Alright, if you could walk at a rate of 2 meters per second, it would take you 1.92 times 10 to the 8th seconds to walk to the moon. Is it appropriate to report this time as 1.92 times 10 to the 8th seconds or 6.09 years? Well, this is where you have to think of why would you, is this more relatable, or is 6.09 years? Do you want to say, well, it takes me this many seconds, or it takes me this many years? When you're talking about something like that, you're going to probably want to talk about it like this. Okay, this is where distinguishing between the two different types. Here in the ocean, the seafloor moved 475 kilometers over 65 million years. Is it appropriate to report this rate at 7.31 times 10 to the negative 5, or kilometers per year, or 7.31 centimeters per year? I would again go here because it just makes more sense. We have this number is not as big. Okay, your assignment, page 55, 1 through 27, odd. Remember, in a separate sheet of paper.